Hi guys, I hope you're good since last video. First word is that I want you to remember that I'm using 3 small models that can be run locally to have a more realistic view on what is possible to do at the moment. After, there are the proprietary models, the paid ones, OpenAI, Anthropic, which would be prone to less errors and would ask less efforts in prompting and iteration process, but the local models still provide a frontier view of what is working best for the open-sourced models just using a local laptop. We are going to have 2 classes in this video, one really simple with a self-explanatory description of what is expected as output, another which will have more fields and will be more complicated, requesting more understanding effort from the LLM on computing the result from one output field to another expected field output. We will go over the details in how to get structured output using different techniques, and we'll run those examples incrementally together for each of the desired structured output classes. We will be able to see the results for running each of the structured outputs, simple and complicated one. We will, toward the end, sum up our results to do a recap and see which one we are going to choose based on our experiment. Please like and subscribe, as always, and make your own search about the Grass project. Referral link is in the bio and comments. They are preparing an airdrop on the Solana network, and there is incentive for passive points accumulation when inviting your friends to run the Chrome browser node or the background process one. Okay, let's start. Structured output classes. So let's see those classes. We use the base model from Agentic. So Langchain core, Agentic. We need the fields. You can also have a validator if you want to. We're just going to keep it simple, the field. So we're going to call this one add count. So this is a structure that we're defining here. So it will always add 10 to any number. Different fields. The initial number is a list of int. The field, we have a default value. It's an empty list, and initial number present in the prompt. This is a description. Calculation, it's a string. So here is a string. It's an empty string at the beginning, and the description details of the calculation to have create the result number. Result, it's an int, and the field has a default value of 0. Get the sum of all numbers, then add 10 to the sum, which will be final results. So here we are describing the structure, which is the complicated one. After I'm gonna be going the other one, which is the simple one. And here we have an error field, which is the last field is a string. An error message when no number has been found in the prompt. So for the simple output structure, call it create bullet points, create answers in the form of 3 bullet points. Bullet points is a string. The field has a default value of an empty string. On the description, answer creating 3 bullet points that are very pertinent. Type of query, it's a string. Could be a boolean, but we just use a string, field, empty string, we describe it. Delete the query is just a sentence with the word sentence, or a question with the word question. So it's just gonna structure the output first way. So we're gonna go through different ways of doing that. So here we're gonna use a parser, which is gonna be using the Agentic output parser method, and inside we define the class structure that we have made here, which is a Agentic object. The prompts, we use the prompt template from LangChain. The template answers the user query, and we're going to inject format instruction on the query. After we have here format instruction, which is going to be getting the parser, get the format instruction. Or we can just do format instruction equal parser.get format instructions, and after here we just add this value. So here we're using this method, get format instruction, which is from the Agentic output parser class. And this one is going to be injected as a partial variable into the template, while the user query is an input variable, which is going to be used while we invoke the model. That's when we're going to decide what is the query. So the prompt on the model, we start building the chain prompt, and here we got the model and the output. I can put it together, I think, and the query. So we invoke the model with the query, which is here. That's the query. Use a dictionary. It's going to pick the key query, the word, and get this sentence. Tokyo is a #1 city to have more than 20 million inhabitants. Read description of tool and provide right answer. So there's a bit of instruction in it, and there's the query. And the response, we use the parser. The parser here, and the add count structure output that we want. So with those 4 parameters as a dictionary. So that's what we expect, is to get a dictionary with those answers. So we get the output, and we're going to invoke the model. We could use the parser into the chain. We could put it into the chain directly, but here I'm just doing 2 different invokes. You can do 1 invoke. You don't need 2, actually. We use the Grok Mixtral 7B model, and we're going to call this first structured output and see how it's going to be. What's the result? So that's the first way. Okay. So it got the number 1, it got the 20 million as a 20 million, which is good. Number 1. So here we got the list with 1 and the 20 million. That's the initial number. Now the calculation, let's see. So it's going to explain here. Sum the initial number and add it 10. Okay. And the result here, that's what makes this structure complicated for him normally. And the result could be the addition of the two. So there's no confusion. And there's no error. This is just the perfect output. Now the structured output, the same, but we're going to use the first way, but with the other one. The second one, the simple structure, is the create bullets. So one is a calculations, one is a calculation, the second one is going to be more some text. Bullet points. I'm not going to change the query. I'm just going to keep it simple. The query is going to be always the same. And we're just going to see what we're going to get. Okay. So we go to bullet points. Little bullet points here. Tokyo has the largest population of any city, more than 20 million inhabitants. So here we're going to more focus into the structure. So we got the bullet points. The answers, they can vary depending on the model that you use. Even here, if I call the model again, it might actually bring the same answer, but it might also bring a different answer. So we got the 3 bullet points, which is good. On the type of query, it has identified if it is a question or a sentence, and has identified it as being a sentence, which is good also. Structured output the second way. So the second way is you're going to use Pydantic output functions parsers. We're going to add here the class. So it's another class that we're going to use. OpenAI functions. We're going to convert to OpenAI functions the class that we have created for the output structure. Put it in a list. We're going to use that one in the chain for the tool, for the model. So the prompt will be the same. Prompt template. So Pydantic output functions parser, which is different from the other one, which is Pydantic output parser. Just for you to see the difference, because here we have the functions. So with that, we will be able to bind the function to the model using the convert to OpenAI functions. So we put this add count inside here in this method. And the OpenAI functions. And we're going to bind it here to our Grok LLM Mixtral 7b. And after we build the chain, so instead of doing two invoke, I'm just going to do one, having a chain with the prompt, the LLM, and the parser. Just for you to see the difference between the first and the second. It's completely different the way we're doing it here. We're using different methods and classes. While in the first one we just used the model, here we're binding it with the class, and the query is going to be injected with the same prompt. So let's see how it's going to be. So we're going to be printing both together, so we will be able to compare to see also how consistent are those outputs. Okay, so here we got the numbers with 20,000,001. The calculation, it says add the initial number values to get sum. So this is wrong. The result is 0, is wrong also. And it hasn't identified any errors. Okay, so the second way is not good. Here we get the numbers. We get the same output here. So it's pretty consistent for the first way. Hasn't changed. Initial number, calculation. Here we got it wrong. Because we just got this sentence, which is not the right explanation. And that's why maybe it couldn't get the result after that. Just output the default value. So it was maybe too complicated. And it couldn't get that result right. So now let's use this second way, but with the simple structured output, the one having only 2 fields, simple descriptions. We're just going to swap here for that class and see if he's better at writing those bullet points and telling us if it is a sentence or a question. So same here, we're going to compare. That's what we will be doing during the video, comparing and checking if it is the same. So the first one, we got consistency in the output because we got the bullet points, it's a sentence. That's good. This is the second run. Yes, it has identified the sentence. And the bullet point, we just have an answer, but we don't get any bullet points, as you can see. So even if you use the same model, you see we got different answer from the first and the second response. While the first response actually has been the same as the one we got before. So this is the third way. The third way is pretty simple. It's just using prompt engineering, system prompt, and human prompt. How do I build this system prompt? User and serial ways with initial. I just give the structure of it, same as in the class. So I give the parameters and also give the description of what should be done for each parameters. So that's what I'm doing for the system prompt. Put it in a dictionary between markdown tags. And I'm going to show an example, markdown, initial number, and I put again the description of each field inside this fake dictionary that I've built as an example, which is just taking those descriptions. As you can see, we have the same descriptions, and we just reported those files and those descriptions into the system prompt. So this is for add count. We're going to do add count first. And here in the human message content, this is how you build those prompts for system message, human message. There is also AI message or 2 messages. Here we just need those 2. And we use the same query. I'm just going to comment this out. After we use the Grok LLM, we invoke. We put in a list those 2 queries, so the system one and the human query. so that the LLM knows that it needs to answer to the human query. And here we're going to pass it. Pass it. We're going to get the content of the response by splitting. Here we said the markdown, so we're going to split here. When we split here, we're going to get a list. Number 0, number 1 will be the inside of the markdown tag, and after we're just going to strip if there is any space, white spaces. Let's see what we're going to get. Okay, so the first one is still consistent, get 100% the same. The second one we get also 100% the same answer, but it's wrong, while the third one is wrong, but we get a dictionary. We get the fields, but they don't have anything. There's nothing into the field, and it says there's a number, no number found in the prompt, so it has identified an error, but there's no number in the prompt. While here there is a number, at least 1, and the 20. After million, I have wrote it using letters just to make it a bit harder. I'm running it again. Okay, so we get the same. We get the same error. Structured output, the third way, but this time we're going to use the simple class, simple structure output with only 2 fields, and using text this time, no calculation. So same prompt, we don't change it. So I just need to change the class so that we can compare. So now I need to do it in all of the examples. And here we need to get the right query system. So we're doing the same here, but we're using the second class fields, so bullet points, and the type of query, and we just put in the description to the parentheses. Same here using our prompt technique. So the third way is just a prompt. So we're gonna prompt and tell to the LLM, this is what I want. Can you provide me that structure as an output and put it between markdown tags? That's what we're doing basically. So it hasn't been working well for the calculation. While here, let's see for the text one. Okay, this is better. Here we still get the same output, which is good. The first one is pretty consistent. The second one, we get the same kind of error, so there's no bullet points. We can see that there is also consistency in the errors. And here we get bullet points, but there's no bullet points. It's actually okay, but still there is a kind of formatting, but it's not a dictionary. As you can see, there's no comma between bullet points and type of query. It has identified that is a sentence, but we're missing the comma, so it will be hard to fetch. Okay. So let's put back everything to add count. Add count everywhere. We get this query. We just want to compare For the next one, which is the fourth way of doing it, and we're going to start with add count. Here we're going to use bind tools and put in a list directly the class that we're going to bind to the LLM. And we're going to use the chat prompt template this time, which is another template. I'm going to put the system and the user query in a tuple. And we're going to use the JSON output tools parser method. And we're going to build a chain, prompt, model, and parser. And we get the response using the invoke method on the same query. Let's run this. Okay, first one is good, as usual. Second one is not good. Third one, same, not good. Here we get calculation, adding 10 to the number of inhabitants in Tokyo to reflect the fact that there is the number one. It is the number one city to have more than 20 million inhabitants. We get 20 million as number. Didn't identify the one. The result is 0, and there's no error. Okay. So this is wrong. That's not what we want. Let's now try create bullet points. So same as the other ones. We're just going to replace all of those classes with create bullet points. And we're going to compare the four different techniques. So what is surprising is to see that it's very, very consistent, even when it's doing some errors. So we get the same error output. So there's no chance to get it right unless maybe doing some more prompt engineering. But here we would just want to be natural and use almost zero-shot prompts to be able to compare and see which one is the easiest and the best. So for the bullet points, we get bullet points identified, but there's no bullet points. We just get a sentence. And here it just has a bit hallucinated. It says statement. It's right, it's a statement, but we ask for, just give him two solutions, which was, sentence and question, not statement. We didn't tell it to tell us that the type of query is a statement. For the other ones, it's consistent. So only the first one has done the job right. The third one is almost perfect, but we need maybe to have a better prompt for it. Let's have a break. Please like and subscribe. So response schema method that is going to be used, the bullet points and the description. This is to build the schema that we want. So here we're not using the class, we're just building our own schema, like that, using the structured output parser on the from response schema method. And after we're going to get this parser that you have built, and we're going to inject it into the prompt as we did before. I just put the prompt here again, so that you can see the same injections of the query, which is here. So prompt and the query. We can even do like this model. That's what you're gonna see maybe in the documentation. and we use the parser. Let's go to the terminal and let's run it and compare. So this time we're going to start with the bullet points and see how it goes. The first one is pretty consistent. Second one. First one we get the bullet points here. And the fifth one is good also. Looks good. Bullet point in the dictionary. We get the value with those bullet points. While here we're missing the comma, so it's not a real dictionary. And it has identified sentence type of query. While the fourth way has stated a statement instead of sentence. Okay, so this is also a good one for the simple structure, but we need to check for the calculation, which is going to be harder. And we're going to see if it is validated for both. So let's use this bonus fifth way with we're going to build another here very quick, another schema mimicking the class that you have creating above. So we're just going to get the fields that we need. So we need all those fields and we're going to build a schema. Okay, so this is done. Schema number 2, which is going to be the calculation one. This one is for the, how did we call it? Create bullet point. Create bullet points. And this one here is for add count. So let's go to the terminal and run it. Okay. Let's fix this error. We miss the commas. So you can't just copy and paste from the class. As here, it is a list. Let's run it and see how the calculations are going to be. Is it too hard? No, we got another error. So it's too hard. So I'm gonna enhance here the prompt by adding an example. So I created a variable with a string showing the example JSON. So we're gonna inject that has a partial variable into the prompt. So let me just put this in a list, as it was a list for the initial number. Just gonna put some random numbers. So this is 40 plus 10, 50. So we want 50 as a result and we don't want any error. on the explanation here that we want. Sum of all numbers equals 40. Just words. We want it to be just written words. Adding 10 to the sum equals 50. Something like that. That's what we want. Let's see now. Let's see if we're gonna get an error. No, it's alright. No error, but no output. So the fifth way, you can just eliminate that way. Don't use it. Too much of a headache. If for any of those ways you have a better way to do it, or you have your own experiment, use the comment section to talk about it. But for the moment, the qualified one is the first way, which is very consistent. I'll run it again just to see. So now it's buffering a bit. We're gonna see, maybe it's gonna output it right. No. Same. So we get the consistency in the errors. That's what we can tell. It's pretty consistent even in the errors, but we don't get the output that we want. Just gonna get rid of the example. Because when it is too complicated, what's gonna happen is that the formatting is not right. So the model is gonna put, I don't know, single quote or double quotes in the wrong place. So at this moment, we're not gonna get the right output, and it's gonna be resulting in an error on the terminal. So it's gonna crash your application if you don't handle it right. I'm just gonna run it again to see if we're gonna be falling into this error again. Yes, so we get again this error, expecting property name enclosed in double quotes. Structured output way, bonus fifth way, ChatGPT. I'm just gonna talk with ChatGPT. So providing an example JSON structure output. Prompt can help the model. So yeah, it's suggesting me to add an example. That's what I did. Why is this happening? Complexity of the task. The model might generate output that mixes natural language and JSON structure, and blah blah blah. Just to say that it's too complicated for it. So now let's see the different ways. Add count, create bullets, the methods. So the first way has been very consistent, respect the schema, the separators, and we use those methods. The second way, get output, the number, no explanation, no calculation, and for the bullet points, no bullet points, just an answer as recognized sentence. And there's more methods here. We need the byte function for this one. So different methods. The third way didn't detect the numbers, no calculation, therefore error field returned an explicit message, no number in query. So didn't detect any number. For the bullet points, we get an answer in a dict, but it's not a dict, there's no bullet points, because there's a missing comma, so it's not a real dict. So this is just a bare prompt, system message, human message. So the third way was that. Or the fourth way we did field all the fields wrongly with some partial numbers detection, but it's a wrong explanation, wrong result. For the bullet points, it's a bit hallucinated using the term statement, and there's no bullet points. So here we're using the bind tools, chat prompt templates with a tuple, system and user prompts on the JSON output parser, JSON output tools parser. For the bonus fifth way, error when no example provided, crashes the app. When example is provided, doesn't detect any number. It's a mediocre result. Very consistent, respect the schema as a separator, so easier to extract the values in a dict. The bonus fifth way. So here what we can say is that, let's put this in white, structure final thoughts. Very consistent in the output, good or bad. So good output will come back always as a good, as before, while the bad output will come back always white, always bad. So the first way, let's talk about the first way. Let's go and read this, put a space here. Okay, no description, super correct, super consistent, understand well the instruction without much prompt engineering. So the second way, incorrect responses, doesn't get what to do for all fields, maybe can handle only one field. I haven't tested, but it's not what we need. Maybe sensible to better optimized prompting, maybe. The third way, very incorrect response, miss in the detection, structure can be missing some parts, would probably work with a little change in the prompt, therefore need longer detailed prompts, I believe. I believe this one can be used with more prompt engineering. The fourth way, very incorrect, act like a temperature 11. We don't want creativity, but a strict structure output. So this one you can eliminate it. The bonus fifth way, nice when not having complexity to the schema, not reliable, and crashes the app. Too much complexity when we introduce too much complexity, and it works better with an example. Still fails to calculate and detect the number. It's good with the text generation, the simple one. So in conclusion, what we're gonna choose, very easy. The first way is to be used, so that's the one that we're gonna use, more reliable. The third way, for prompting, can work, but we need more effort into the prompting and the iteration process. The fifth bonus way, probably always use with example prompt in it and lower the complexity, having less fields in the schema and simple descriptions. So all the other ones won't be using because they really failed their jobs, which is the fourth way and the second way of doing it. So we go for the first way, which is Pydantic output parser, get format instruction and one invocation, easier to understand, the flow with less methods. I think that's the easiest one, and at the same time that's the best one, and it's a Pydantic one, so we don't need more than that. And we can say also it's pretty consistent because we got the same answer. So every single answer that we got was the same sentence, the same wording. So respect the schema, even with some complexity added to it. We've seen 5 different ways to get structured output from LLMs, and we have decided to go for the first one, which was the more consistent and respectful of our desired output format. We have seen that some of the other ones could probably work better with more prompt specifications and perfection, but we are trying to have the more common prompts used by anyone to work fine without requiring any PhD in prompting. Hope that this video was helpful, and it is part of LangGraph side videos in order to have more helper functions on the side, but could actually be used for some other projects and be seen as a standalone video about just structured output in Python using LangChain and LLMs. Hope that you liked this video. Please like and subscribe, and see you next time.